Hello, this is a presentation about OVS-DPDK multi-core scaling and some new features that have been added to OVS 2.15 and OVS 2.16. So often in OVS-DPDK there's a throughput bottleneck caused by a lack of PMD cores to process all the packets on the data path. But we can remove the bottleneck by adding some new PMD cores, however we need to make sure that OVS-DPDK gets to use them. So to give a bit of context, there's a few things OVS-DPDK can do to get the best use out of the new cores. First, it can efficiently assign the PMD cores to pole RXQs. So in this case, the DPDK interfaces, which are orange, have traffic and packets to process, and we can see that the processing is spread between core 1 and core 2. If, however, we had assigned PMD core 1 to the RXQs from DPDK 0 and DPDK 2, well then it might have been overloaded, while core 2 may have been completely idle because it had nothing to do. But even with efficient assignments, traffic can change in time. So another thing OVS-DPDK can do is detect that the assignments are no longer efficient. And if they can be improved, then it can trigger the assignments to be redone. So in this case, core 1 has become overloaded, so the PMD Auto Load Balancer could trigger for reassignments in order to balance the workload across the PMDs again. And the first new feature we'll look at is related to the PMD core to RXQ assignments. So in order to have efficient assignments, the workload needed to process packets from an RXQ is already considered, as we can see on the left-hand side. So the RXQs with the biggest workloads are assigned to different cores. So in that case, the 70% and the 30% went to different cores. But the catch is that at the time it was implemented, there was no PMD Auto Load Balance feature. So there was no way to detect that those assignments had become inefficient over time. And this led to a trade-off being made between optimizing for the current traffic and mitigating against future traffic changes. And the trade-off that was done was to give a same or similar number of RXQs to each PMD core. So we optimized the assignments based on the current workload to a degree, but not as much as we could. However, now that we have the PMD Auto Load Balancer, we have the ability to optimize some more, as we see on the right-hand side. So this is done by removing the need to have a similar number of RXQs per PMD core. So we might group many RXQs which have a low workload on a single PMD. So we can see in this example, DPDK 1, 2, and 3 have their RXQs assigned to PMD core 2, and this leaves PMD core 1 free to deal with the RXQ, which has the greatest workload. So there's some advantages for this kind of approach. So it's not shown here, but if DPDK 0 had not been 70, but maybe had been 95, then on the left-hand side, it would have been a 95% and 20%, and core 1 would have been overloaded. Whereas on the right-hand side, we can see it would have been just dealt, the 95% would have been dealt with core 1. But even in the case where we're not at that kind of overload situation where cores are out of capacity, we can see in the case that we have here, there's not too much available capacity on core 1 on the left-hand side to deal with smaller changes in traffic patterns. So if the traffic or workload increased on DPDK 0 or 1 by more than, say, 10%, PMD 1 would be overloaded. So with the group assignment, the available capacity can be spread more equally across the PMD cores. So if the traffic changes so much that the available capacity is not enough, of course, then the PMD Auto Load Balancer can redo the assignments. Okay, so the second feature we look at is pin and non-isolate. So there is a facility for the user to directly assign some of the PMD cores to RXQs themselves. And this might be done in cases where the user has some knowledge about the interfaces and traffic pattern. For example, in this case, the user might know that DPDK 0 will have lots of traffic and needs 2 PMD cores dedicated to it. Up until now, the PMD's cores used for pinning were then isolated from OVS assigning other RXQs to them. So if there was spare capacity on them, OVS would not be able to use it. So for example, if DPDK 0, RXQ1 and RXQ2 only needed 60% each of a PMD, there would be an extra 40% on core 1 and core 2 that would not be available for OVS to use. Whereas with the pin and on-isolate, OVS can get access to that available capacity. Okay, so we've mentioned the PMD Auto Load Balancer a few times, and it has a few decisions to make. So the first thing it needs to think about is there high enough load on the PMDs to warrant doing some reassignments? Because if we're at 5% and 10%, there's probably no point. And the second one is, will things be better if the reassignments are done? And these decisions may vary depending on setup, or at least the user may want them to vary. So we've added some user parameters. So we've always had the true or false to turn it on because it's off by default. That's an existing parameter. But the first new parameter we've added is the load threshold. So how loaded should a PMD core be before we consider that we might want to trigger reassignments? Well, why not let it reach 100%? Because if that happens, you're probably already at a stage where you have a massive amount of RXQ drops. So it would be better to detect at some point before that the traffic is rising on the PMD. So let's say maybe 70% or 80%. In this case, it's set to 90. And then we can detect that and maybe do the reassignments before we get to the overloaded condition. There's also a parameter to say how often the reassignments can be triggered. So user might just want to allow that to happen every few hours. There we go. And finally, the PMD Auto Load Balancer will estimate if the new assignments will make things better by doing a dry run. So it'll do that by checking the variance of the PMD loads currently and what it would be estimated after reassignments. And if there's an improvement in the variance by, in this case, 50%, it will trigger the rebalance. Okay, so we've looked at 3 new features that can help with multi-core scaling: group assignment, pin and on-isolate, and the PMD Auto Load Balance parameters. And there's more info at the links below. Thanks for listening.
So I'd like to thank our presenter, Kevin. Kevin, if you're here, then please join me on voice and video. It's good to see you again. It's been a while.
Hi, Ben.
So we have time for questions. I hope that people will start posting some. I don't see any yet. But as long as we're here, do you have any additional thoughts you'd like to share with us while we're waiting for some questions?
Yeah, well, I suppose one thing to mention is that this is just about trying to use the resources that we've assigned to OVS more efficiently. But of course, there still is cases where you can just under provision. So it's not the panacea for performance. It's just to try and, when you do try and scale things, as we often see is needed with OVS-DPDK, by giving it additional PMD cores, is to get access to the cycles on it. Another thing that's not mentioned here, but is one of the blogs, is that by using multi-queue on the devices, like and using RSS in the NICs, that can spread the load efficiently across a number of queues, and that makes it much easier for OVS to try and place those queues with PMD cores, because it's a smaller granularity. So we don't have a one RXQ that uses a whole core. We maybe split it into 2 RXQs that uses 2 cores. So there's a few things mentioned in the blogs that might be worth, if people are interested in this, it might be worth them having a look.
Blog entries are such good resources, and I'm glad that you've posted some.
Yeah, my pleasure.
Go ahead.
I was going to say they're called articles now. We've gone up market, I think.
That's definitely a fancier name than blog. But I hope that they have still managed to be relevant and useful. I don't see questions showing up, so I apologize that they didn't. But people probably are kind of tired. I know that I am. And thanks again for your presentation and for the work behind it.